Conditional probability. The probability of an event occurring given that another event has already occurred. It is denoted as the probability of B given A. Independent events. The occurrence of the events does not affect the probability of the occurrence of the other event. It is denoted as the probability of B given A is equal to the probability of B, or the probability of A given B is the probability of A. Events that are not independent or dependent. Multiplication rule. Multiplication rule for the probability of A and B. The probability that two events A and B will occur in sequence is the probability of A and B is equal to the probability of A times the probability of B given A. For independent events, the rule can be simplified to the probability of A and B is equal to the probability of A times the probability of B. Mutually exclusive. Two events A and B cannot occur at the same time. A and B have no outcomes in common. The addition rule. Addition rule for the probability of A or B. The probability that events A or B will occur is the probability of A or B is equal to the probability of A plus the probability of B minus the probability of A and B. For mutually exclusive events A and B, the rule can be simplified to the probability of A or B is equal to the probability of A plus the probability of B. Here are some examples. Can select a card from a standard deck. Find the probability that the card is a 8 or an ace. Solution. The events are mutually exclusive. If the card is 8, it cannot be an ace. So let's apply the addition rule, which is the probability of A or B is equal to the probability of A plus the probability of B. So the probability of 8 or ace is equal to the probability of 8 plus the probability of ace. So there are 4 8 and 4 aces. 4 over 52 plus 4 over 52 is equal to 8 over 52. 8 over 52 is equal to 0.154. The second example is, two cards are selected in a sequence from a standard deck. Find the probability that the second card is an ace given that the first card is an 8. Assume that the 8 is not replaced. Solution. Because the first card is an 8 and is not replaced, the remaining deck has 51 cards, 4 of which are aces. So it is unconditional probability. The probability of B given A is equal to the probability of the second card is ace given that the first card is an 8 is equal to 4 over 51 is equal to 0.078.